So guys, in previous lectures, I was using a term operators again and again, and we even saw a bash operator in the default DAG file. In this lesson, we are going to discuss operators concept in detail. So what is the term operator? An operator represents a single task in a workflow that helps to carry out your task. Like I mentioned in terminologies lecture, DAGs only describe how to run a workflow and they do not perform any actual action. On the other side, operators determine what actually gets to be done when your DAG runs. Like in tutorial DAG, there we had 3 tasks performing some bash commands. To run those commands in reality, we had used bash operator there. Now talking about some key points on operators. Operators are usually atomic. With the term atomic means that they can stand on their own and they do not need to share resources with any other operators. But keep in mind that this atomicity property need not to be always true. Operators are idempotent, which means that your operator should always produce the same result no matter of how many times it is run. Once an operator is instantiated, it is referred to as a task. There are different kinds of operators available out there, like sensor operators, transfer operators. They all are derived from the Airflow's base operator class. As mentioned above, operators are atomic and they do not share information between them. But in case if two operators need to share some information, they can share it by using an Airflow feature called cross communication or XCOM. On this, what are these XCOMs and how do they operate? We'll talk about it in a later lecture. Now talking about its categories. Operators in general are classified into 3 main categories: sensor operators, transfer operators, and action operators, or you can say simply operators. Starting with sensor operators. Sensors are certain type of operators that will keep running until a certain criteria is met. Like in your DAG, you may have a task which needs to wait for input file to come at a certain location. Sensor operator will keep on checking that location on regular intervals and will only move ahead once the required file arrives. Not only file, sensor operators can be used in any case where you need some event to get happen before other tasks can start. Its examples include an HDFS sensor waiting for a file landing in HDFS, a normal file sensor, etc. In fact, we have a separate lecture on file sensors demo in this course. Then transfer operators, as the name implies, moves the data from one location to another. We have transfer operators like MySQL to Hive transfer operator that moves data from MySQL to Hive location, and S3 to Redshift transfer to transfer the files from S3 to Redshift system. Then we have just action operators, or simply called as operators. These operators are used to perform various actions according to their type. The operator name itself will tell you what action it is going to perform. The bash operator that was used in tutorial example to trigger some bash commands is one such example of action operators. Not only bash operator, we have more action operators like Python operator to call an arbitrary Python function. Then we have Hive operator to execute any Hive script, BigQuery operator that executes Google BigQuery SQL, and many more. Apart from these operators, Airflow provides us a number of pre-built operators for many of the common tasks. Throughout this course, we will be using many operators in different lectures. And yeah, not only pre-built, you can even custom build your operator depending upon your particular task needs. That's what makes the Apache Airflow an extensible framework. You can extend it to execute any kind of job or task within your DAG. So guys, this was like a theoretical overview of operators. As we go along with this course, we will learn how to implement different operators in a DAG file as per our use case.